Good morning, children. I welcome you all to today's session of science. We are on to chemistry, and today the chapter which we will be dealing is your chapter third, metals and non-metals. Right? Please follow me. Chapter. Now, children, you all know metals and non-metals have existed on this earth since ancient times. During excavations, these were found. Right? Basically, near Sindhu River, where the it is believed that most of the civilization originated from there. Ancient time has it that iron was used during ancient age. Then many metals like gold, silver, iron, copper, lead, and tin were known. During Vedic period also, metals and non-metals were used. At present, children, you will be very surprised that 118 natural and synthetic elements are known. Right? How many? 118. And these elements have been classified into metals and non-metals. Out of these, children, 80% elements are metals and 20% are non-metals. Right? Okay. Now, there are many uses of metals and non-metals in our day-to-day life. We look around and we will see a lot of things which are made up of metals, especially iron and aluminum. The entire kitchen is dominated by steel and aluminum, right? Our rooms, almirahs, and all that are made up of iron, right? So, wires are made of copper, bulbs, inside the bulbs, there are tungsten. So, lots of metals and non metals are being used. We inhale oxygen, which is a non metal. Now, metals are those elements. Now, we are here, children. On this point, metals are those elements which can easily donate or lose electrons to form a positive ion. The valency of each metal depends on the number of electrons donated by it, right? As you can see here, Na, it in the first equation you can see that sodium, it donates one electron to form Na plus, which is an ion, positive ion. Similarly, potassium donates one electron to form potassium ion, and magnesium donates two electrons. Right? Now, properties of metals. The physical properties include, first being the state. The metals are solid at ordinary temperature. Exception is mercury. Malleability. Malleability refers to which can be beaten into thin sheet, right? When a metal can be beaten into thin sheet, and this is a property of, like, property of metals like silver. On the top of sweets, we have found that there is a layer of silver or gold sometime even, and that is formed by beating a small piece of silver, and then it gets changed into sheet. Ductility is metals can be drawn as into thick wires, right, which is called ductility, right? These are the properties of metals. Conductivity. Metals are generally good conductors of heat and electricity, right? Remember this, children. Metals are generally good conductors of heat and electricity, right? Example being copper, from which wires are being made. Metallic luster. Yes, most of the metals possess shiny surface. This property is called metallic luster, right? The shine. Then hardness. Most metals are hard. Melting and boiling points, they have high melting and boiling points. And sonorous is that they produce sound when being hit upon. They collide with other substance to produce sound, right? That is called sonorous. Now, with all that, we move ahead to non-metals. Now, these are the elements which accept electron and form negative ions. Like whatever metals, they donate electron to form positive ions, and here there are non-metals which accept electrons to form the negative ions. Like see here in this, Cl plus E will form Cl minus, which is the negative ion, and oxygen plus two electrons will give O2 minus, which is also a negative ion. Now, physical properties state they exist as solid, liquid, and gases at ordinary temperature. Carbon, sulfur, phosphorus, etc. are solid. Bromine is liquid, whereas hydrogen, oxygen, nitrogen are gases. Now, brittle. Brittleness. What is brittleness? It is the property when non-metals, when hammered, they break into pieces. This property is called brittleness. In metals, whatever they were malleable and ductile. Conductivities, they are bad conductors of heat and electricity, right? Metals were good conductors and non-metals are bad conductors. Luster, they do not possess any metallic luster, no shine is there. Softness, most of the non-metals are soft except diamond, which is the hardest substance. Tensile strength is low, they break very easily. Melting point and boiling point, they have low melting and boiling point, like low melting and boiling density. They're lightweight in nature also. Now, they're all metals exist as solids, non exist as solid in room temperature except mercury, right? Then melting point of metals is that all of them have high melting point, metallic luster, right? They possess an allotropes, right? Now, chemical properties of metals. They react with oxygen to form metallic oxides, right? What will they form? With oxygen they form metallic oxides. 4Na plus O2 will give 2Na2O, right, which is sodium oxide, right? Well, now also there are certain, these are called when they react with oxygen, these oxides are base, generally base, alkaline oxides or basic oxides. But there are also amphoteric oxides. Amphoteric oxides are those uh, which react both as acids as well as bases. Oxides which react as both acids and bases to produce salt and water is called amphoteric oxide, right? Like Al2O3, aluminium oxide, it's an amphoteric oxide. All metals do not react with oxygen at the same rate. Metals such as sodium and potassium react vigorously with oxygen and they catch fire. This is very, very important. Children, metals such as sodium, potassium react vigorously with oxygen. It catch fires. That is why sodium or potassium are generally kept in kerosene oil, right? They are generally kept in kerosene oil. Now, what is anoising? Anoising is the forming of thick layer of aluminium oxide. It is the process of forming thick layer of aluminium oxide. Reaction of metal with water, they form metallic oxide with hydrogen is liberated. Potassium and sodium react violently with cold water. Their reaction is so violent and exothermic that they evolved hydrogen immediately catches fire. Right? Now magnesium, it reacts with hot water, not with cold water, right? So these kind of reaction occurs with water. Now we come to reaction of metal with acids. With acids they form salt and liberate hydrogen gas, right? Right, you can see here sodium, magnesium, aluminum, all they react with, see this reaction here, sodium is reacting with HCl to form NaCl with hydrogen, right? Metals with copper, silver oxide and gold, they do not react with dilute hydrochloric acid, right? Metals react with dilute sulfuric acid to form metal sulfate and hydrogen gas, right? They form metal sulfate and hydrogen gas, right? As you can see from this chart, 2Na plus H2SO4 will form Na2SO4 plus hydrogen. Okay, now a very important compound is here, which is called aqua regia. Aqua regia is the freshly prepared mixture of concentrated HCl and concentrated nitric acid with 3 parts concentrated HCl and 1 part concentrated nitric acid, right? How do metals react with solution of other metal salts, right? They react on the basis of this reactivity series, which is here. You need to remember this in sequence, right? You need to remember this in sequence, activity series, this one. K, Na, Ca, potassium, sodium, calcium, magnesium, aluminium, zinc, iron, lead, hydrogen, copper, mercury, gold, silver, and gold. This is their activity. Means the element which is at the top is the most reactive, and then the reactivity decreases with gold being the least reactive. Then there is also an electrochemical series, right? Now there are certain terms which we need to remember. First is oxidation potential, right? This is the potential which is there when electrode is negatively charged with respect to the solution, right? If the solution is zinc sulfate, then zinc rod is taken and the charge is given negative. Reduction potential when electrode is positively charged with respect to the solution, like copper sulfate, and the rod is of copper with positive charge, right? Standard electrode, the absolute value of single electrode potential can be not be measured directly. Only the difference in potential between the two electrodes can be measured. To compare the electrode potential, standard electrode potential should be known, right? Standard electrode potential is the potential difference between metal electrode and the solution of its ions of unit molarity, right? Okay. Next we come to the electrochemical series. Now you can see it is almost same as the activity series with lithium, potassium, calcium. This is the electrochemical series here, right? With lithium, potassium, see here, lithium, potassium, calcium, sodium, magnesium, aluminum, zinc, chromium, iron, then copper, nickel, sorry, cobalt, nickel, tin, and so on and so forth. Characteristics: being a metal which is higher in the series is better reducing agent than the one which lies lower. All metals with negative electrode potential are stronger reducing agents. The metals have the tendency to metals on the top have the tendency to lose electron, whereas on the bottom they have the tendency to gain the electron, right? Now the electropositive character of metal decreases from top to bottom in the electrochemical series, and a metal higher in the series will replace the metal from its solution which is lower in the series, right? Now let us see what are the causes of chemical combination. There are two causes. First is to acquire stability, and the second is tendency to acquire noble gas configuration, which is having 8 electrons in the outermost orbit, right? Just to fulfill that, these elements they combine with each other. Now let us see this electronic theory of valency, which will perhaps be the last topic for the day. Now Thomson and Rutherford and Bohr had provided the early development of the nuclear theory of the atom. Their work helped in understanding the structure of atom and electronic configuration of atoms with the evolution of electronic concept of atom. Efforts were made to find an explanation for the combining capacity of the atom. Since the theory was based on the electronic configuration of atoms, it was called the electronic theory of valency. It owes its origin to Coasel and Lewis. They observed that the valency of an element is closely related to the number of electrons in the outermost orbit. Right? You can see here in lithium, beryllium, boron, and carbon that the electronic configuration and the valency is almost identical. Right? So it is clear from the table that the valency is either equal to, right? See, in the last orbit, if there is one electron, then in the valency also there is one electron, and so on and so forth. After 4, what happens? They decrease it from 8, right? So we get 3, 2, and 1 and 0 electron, right? So let us stop here. I hope you enjoyed it as much as I did in making it. And until we meet again, it's a goodbye.